Hello and welcome to problem set 28. Today we are going to add to our analysis of graphing rational functions. So f of x. When we say rational functions, we mean functions that are rational, which means you're going to have that division going on. And we have some polynomials in the top. That's a 7. And bottom. All right, so how do we address this? Well, there's a few steps that we have to take in order to make sure that we're graphing these polynomials correctly. The first thing is I need to find its zeros. Next, I'm going to find your vertical asymptotes. Third, I'm going to find the end behavior. And that's as far as we're going to go. So up to this point, I believe you've only done vertical asymptotes and end behavior. So let's add in the zeros. How do I find a zero? Well, it's simple. I set the numerator equal to 0. So what does that give me? Well, it gives me x times x minus 7 equals 0. So for what x values is this true? Well, when x equals 0 and when x equals 7. So my zeros, and I should list them, are 0, 0. And 7, 0. Remember, x always goes first. Then I am going to find my vertical asymptotes. That's when the denominator equals 0. So for what x values is that going to be true? Well, x equals -5, x equals -2, x equals 2, and x equals 5. Now these are lines, not points. Zeros are points because they have a y value of 0 and they have an x value. These are lines because we're not touching that entire line. Finally, to find the end behavior, we take the limit as x approaches a really big number, aka infinity, of our function. Now, remember that the only thing that really matters with our function is the highest power terms. So if I were to multiply out the top, I would get x squared plus a bunch of other stuff, right? It would be x squared minus 7x. But I really don't care about the other stuff because that highest power term is going to take over the entirety of that function as I'm plugging in really big numbers. Now on the bottom, I have x times x times x times x. What is that? That's x to the 4th plus, and then there's a bunch of other terms. There will be x cubed terms, there will be x squared terms, there will be x terms, and then constants. But I don't care about those because the one that's going to overrule everything is going to be the x to the 4th. Now, as we plug into this limit, I want you to be exceptionally careful to look at whether or not this is going to be a positive or a negative number. So I have infinity squared over infinity to the 4th. This term is going to take over, so it's going to be 0, but it's going to approach that in a positive way because you have something squared over something to the 4th. Both of these numbers are positive, so it does go to 0, but from the top. Now, if I plug in negative infinity, let's see if we can fit it in here. I get x squared plus all these terms over x to the 4th plus all these terms. But when I plug in negative infinity and I square it, that becomes positive. When I plug in negative infinity to x to the 4th, that also becomes positive. So this still approaches from the positive 0 side. Now what's the consequence of that? Well, when I'm graphing, here's what it's going to look like. I can first start by marking my zeros. So 1, 2, 3, 4, 5, 6, 7, that's a 0. I have 0, 0 as a 0. Okay? Since these are all two odd powers, right, to the first power, we know that they are all crossing zeros. So we expect it to cross the x-axis at those points. Now, I need to mark my asymptotes. I have 4 vertical asymptotes. X equals 2, or sorry, x equals -5. Let's go back a little bit. 1, 2, 3, 4, 5. I would highly recommend not marking the scale on the y-axis because you really don't know what's going on. So we don't want to deceive or try and like twist the truth at all, so I can't mark that. I'm going to be accurate in x, hopefully, but not in y. So I'm going to mark x equals -5, x equals -2, x equals 2, and x equals, oh, that kind of missed, x equals 5. So from this point, I would end up with one of two graphs. I would end up with a graph if it starts up here, going through, up, down, and then up. Or I could start with a different graph. The trick here is I have to figure out, did I do it wrong? I might have done it wrong. That's cool. Or the book might have done it wrong. Okay. Anyways. Nope, we're doing it right. Okay. So, what I'm going to do is I am going to start based on my end behavior. So, our end behavior at infinity gives us a positive 0, which means that I start that way. Okay, it's going to approach 0 as I get bigger and bigger numbers from the positive end. On the negative side, it's going to approach 0 from the top as I get closer and closer to 0. Why? Because I got positive zeros here for both ends. Now, let's see if this actually works with the function. I think we're going to see some issues, or I copied the problem wrong. So, let's find out. This is the scariest part. Okay, so if I start here, and I know that I have a 0, I have to go through that 0. If I go through the bottom of an asymptote, I have to start at the top. So if you go down, you're still going down. Unfortunately, there's no zeros in here. So I have to loop back around and go back up. Then I am going to start, I'm going up, I'm going to continue going up. That way. Why didn't I loop back around? Because I have a 0, so I'm allowed to cross and keep going. Since I was going up here, I'm going to go up here. Since there was no 0 here, I had to loop back down. So now I'm going to start up here. And this is a good way to check your work. Your positive infinity and negative infinity end behavior must match. Okay? So, in order to get that to happen, you have to make sure that you check both of them, like we did here. And then you start on one side, and if you did everything right, you'll end up with the other side. Now, our book got a completely different answer. Oh, because I missed a minus sign. That's fine. Anyways, so that, my friends, is problem set